Hello everyone, this is Bradley. Today this is a fundamental tutorial talking about the object mesh data node. This is a topic that I would like to discuss for a very long time, and this is potentially a prerequisite to successfully understand other tutorials in the future. So I have to do this in advance. This series may be long and I don't even know how many parts we are going to have. Today this is just a part 1 and you may need to wait 10 years for part 2 coming out. Who knows? Whatever, let's start. So here's an example that has been used to answer a question on the Stack Exchange. So people asked how to generate such kind of black hole geometry or relativity or whatever stuff. So he was asking for mathematical functions. And there's a developer of animation node who answered these questions with the mathematical function. It's actually extremely complicated. And it's actually super complicated if you goes to that post and look at that. So I propose another ways. So in these ways, instead of using billions of nodes, you only need 5 nodes in total to get this done. Although it might not be super mathematically correct, but it gives you something that looks right. So if I do not tell you this is not mathematically correct, you probably do not realize this is not mathematically correct. So despite the fact that this is not super accurate, but it's easy to make. So it depends on what you would like to do, and it's procedural. You can tweak the values, whatever. Basically, what this tree does is I have a plane. And I subdivide that. So I load the modifier and deform this mesh use this object controller, and I finally output a new target. And this controller, I can move that so that I change the location of this black hole center. And this is basically idea. So this is just one example that's to use this object mesh data node that loads a mesh from and whatever sub objects with its modifier information. There are many other functions. For example, in the past, if you have watched my instancing object tutorial in animation nodes, there's a node which is called instancing object presets. It's probably the most efficient method to instance an object and so on. Much better than the normal method that you use the object instance. Although there are pros and cons in both kind of method, but sometimes you just have to choose them accordingly. If you want the efficiency or if you want the variability and so on and so forth. Basically, yeah. There are many other usage of this object mesh data node, but today we're not going to talk about its advanced usage, but basically just to talk about the node itself and some problems that you were going to face when you work with that. So here, if you select this object mesh data node, by the way, its actually name is called mesh object input, but basically they're the same thing. If you hit Control A and type in object mesh data, you do see an object mesh data node, and it's basically the same thing. It's just a kind of alias. So you don't necessarily worry the different names, they are the same thing. 100% the same thing. And if you select the node and hit U, and it goes to socket settings, you can see there's a lot of hidden options. There's another way to find this hidden option. You just hit the M panel and you find these hidden options. Basically, it's also 2 different ways to call up the same menu. 2 kind of shortcut keys, U or N, whichever way you prefer, but whatever. So there are lots of options, and I'm not going to talk about all of them, obviously. You can look at the menu actually. However, one thing I want to remind you is sometimes sometimes not all nodes will output these many things, even if it's related to mesh. For example, this node tree for this kind of setup is actually not really correct. There is a better way, it's just to use this grid mesh instead of using a plane. And the advantage of this grid mesh is that instead of having a subdivision modifier, you can control its division basically by this X and Y. So if you hit W and it goes to data input, you can find a integer input for both of them, and you can increase the subdivisions and basically use same thing for this one as well. like type that to 5. So you have a subdivided plane. So you don't necessarily generate a plane in advance. So, but in this case, if you hit U and it goes to advanced setting or socket setting, you only find a mesh. So what if you would like to know more information like its vertices, location, vertices, normal, vertices, polygon center, polygon normals? There's another way which is called mesh info. It will tell you many information which is basically the same as this object mesh data. It's just a kind of two different ways. So you can even put this mesh and find the same information, although I don't know why you need to do that, because basically to tell the same information. Vertices is basically just vertices location, vertices normal, polygon center, polygon indices, edge indices. Basically, they are corresponding. There are several things that's not overlapping, but usually I don't worry about them. I've never used these options at all, actually. So this is just kind of a whatever trick. But talking about this node, what I would like to say, what's important is actually its input. So instead of its output, what's important is actually its input. So if I linked this object, and you can see our newly generated object, which is called a target, and if I goes to the UV maps, you can see there's nothing, literally nothing. There's not even whatever stuff, because this is a mesh that has been generated with animation nodes, and the animation node does not know what kind of information you want to put into an object mesh data. So what you need to do is you need to load the UV, and immediately in this target object you will find the UV map, and this UV map will be the same as the plane. So if you edit the UV, it will basically show the edited UV as well. Although it's not supposed to be correct because the plane is a plane, but the target is not a plane. So I don't know whether you really would like to use that or not, but sometimes this is something that you need to be aware of. Another important thing is load vertex color. So if you add a vertex color in the plane and goes to target, and we're going to hit the load vertex color again, and it will load the vertex color. There are many other ways, for example, to add a vertex color to a generated mesh. For example, the insert vertex color layer, insert UV map, or get UV map, or get vertex color. These are all options, but just be aware that if you're trying to get UV map or get vertex color layer, then you also have to enable this load vertex color or other things. Because for example, here now we are trying to get a UV map, and the UV map can't be empty. So you just type a UV map. So let's type a UV map. And it still says the mesh does not have a UV map with the name UV map. The reason is because you didn't load the UV map. So these are all kind of questions that you will raise when you're using this object mesh data node. So the hidden options are very important, including its load vertex colors. Be cautious when you're working with these options. Next thing that I would like to talk about is what's actually an object mesh data. So previously we see a lot of outputs, for example, vertex locations, polygon center, and all whatever stuff. Basically, these are mesh data, but is animation node the only way that it tells you what's an object mesh data? I think there are more ways, but I'm not a developer, so I suppose you can find more information from the data API. But there is a kind of more native way to know what's actually an object mesh data, which is this mesh tab. So you can see there's a lot of tab. You can see the transform tab, the physics tab, modifier tab, and so on. But here is a mesh tab, and these whatever listed are basically the mesh data. So you can see the vertex group, shape keys, UV maps, vertex color, and so on. And it's actually kind of important. One aspect of its importance is what I have discussed in the past. So here is the object instance node. I've discussed this in my instancing object tutorial, so I will only briefly recap that. So I'll only briefly recap it. So here we can see two kind of copy. One is copy full object, the other is deep copy. So copy full object will copy everything except for mesh data, but the deep copy will copy the mesh data. So what it means is there are lots of things which is not mesh data. For example, modifier, constraint, where's constraint? Constraint, physics, and the particle system, and so on and so forth. None of them are mesh data. However, which means if you are trying to copy, you're using object instancer to instance an object, and you wish them to have the UV map vertex color information, and you want them to be independent from the original mesh, then you have to use the deep copy. Otherwise, it won't work. On the other hand, if you would try to copy the modifier or constraint, then you have to enable this copy full object. Personally speaking, I just enable these two of them without thinking, brainlessly. But I think understanding the difference between two is still kind of important. So this is just kind of idea. And there's another important aspect of the importance of mesh data is that, so here, if you're looking at this target object, you can see it's kind of very jaggy. We see all these polygons. Normally, the way to solve that is just right click and shade smooth. And now it looks kind of smooth, very nice. You do not see polygons anymore. However, if you enable N, so in the N panel, you can see the animation node tree. And if you execute the node tree again, it goes back to that flat shading. So if you enable the shade smooth again and then you execute the node tree again, it goes back. The reason is that this object mesh data node does not pass the information of shade smooth to the target object, and this target object is generated by animation node. And as has been explained previously about this load UV and load vertex color, animation node do not know whether you would like to have this object shade smooth or not. And by default, you just assume, oh, you don't want to shade smooth this object, and your object will never be shade smoothed. And since the animation node is creating an object for every execution, so it will overwrite your shade smooth that you have done by your right click. So how do I actually shade smooth this object? There is a very easy way. Just Control A and shade smooth. And you can find that there is a node which is called shade object smooth. So now it has been shaded smooth. So if you would like to shade smooth, you just use this method and so on. And what if you would like to auto smooth? I don't know if you actually work. Yeah, it seems actually you can just enable this auto smooth. It will be fine. Another important thing is that it's possible because animation node will only overwrite the mesh data, but it does not overwrite the object data, which means you can transform this object as you wish, and you can add a modifier as you wish. I don't know why you would like to do that, but so even if you change the frames, execute the node trees, all this modifier will be kept on this object without being overwritten. So only when you are trying to update the mesh data that sometimes you have to concern about using nodes and other things. For example, load UV, load vertex color. Otherwise, you're just free to change anything. So even add a physics probably fine. So basically, this is kind of idea. So there is one last thing that I would like to mention for today's part is that if we add a material, so now we're seeing a plane on the left side. Let's render this image and see what we get. And then we see a geometry on the left side, which is good. Let's add our plane. And let's add the same emissive material and render that again. And you can see previously we did not see this plane, but once we add a material, it will show on this gray background. Now we see the plane and this deformed mesh, which is good, which is not good because many times you don't want to see this plane. Okay, so if I disable this plane in the render, and then I render this image, and you can see I do not have this the original plane anymore, but my target also looks kind of weird. Why? Why it has not been deformed? The reason is that this mesh, actually just looking at this mesh, is no longer being deformed. What the heck? The reason is actually that so basically there are three kinds of options I generally use. One is an eye icon. It actually says hide in viewport, and it's temporarily hide. Be aware of this. It's temporarily. So it actually does not. It basically, how should I say? It's basically just a temporary. But there is another option which is disable in viewport. If you disable in viewport, and this object will not be considered at all in this entire Blender file, and the animation node will not be able to retrieve enough information, especially for its modifier. Because if you do not want anything to be shown in the render, then why do you want Blender to read into its modifier? So basically, it's just like you disable the modifier using these two options. So be aware the huge difference between the disable and hide. So the screen at the monitor icon and the camera icon are disabled, but this eye icon is temporarily hiding in viewport. So here's a very interesting thing. If you go to visibilities, it says showing render and showing viewport. You can see it's actually disabling the monitor and the camera. It has nothing to do with the eye. And in fact, you do not have control over this eye using any regular methods. There's not even a data path for this eye. And also here's a very interesting thing is the animation has the ability to change the visibility. And it says hide in viewport and hide in render. It's actually the same as these two options. It's just the reverse. So if you check them, then it will hide everything without affecting this icon. So this icon is not actually controllable by either Blender panels or animation nodes. So this is one important thing. Why it's actually important? Because whether you disable in viewport or whether you disable in render, or you put that into a collection, all the linkage about its modifier will be cut. So the animation node cannot read into modifier. So even if you enable the reading the modifier, it does not work. This is not a bug, it's an expected behavior. But it causes issue when you're trying to use the animation node to deform a mesh with its modifier. Okay, so I hope this is kind of clear. So what's the problem in this case? The problem in this case is if you try to hide the original plane, you will always have a inconsistency between the viewports and the render. This is a very huge problem if you are using the animation node to deform a mesh. So is there any way to solve this problem? There are several ways. For example, there is one way. In this object mesh data node, we can see there is a use word space. If you disable this use word space, what will happen is you can keep this plane enabled, but you can move this plane away. This object will still be made or being produced based on from the word origin. So let's clean up its and in such a kind of case, you no longer need to worry whether it's not being seen by the camera. So it's basically you are not really hide that in camera, or you're not really hide that in render, but you do not see that in render. So this is one solution or one workaround to solve the problem. There's another way that I personally use is that if there's another way. It's basically, I'm just like going to hit this eye icon, and instead of using this render image or render animation, I'm going to the view and the render viewport image. So now, even if I hide this object, the linkage to the modifier has been kept. And you can just try to change that to the viewport shading and disable the overlay, and then goes to the view render image. It'll basically do the perfect job for you. Personally speaking, I prefer this icon method with this viewport render image. And this is not only usable for object mesh data node. Many times, for whatever reason, you may have a kind of inconsistency between the viewport and the render. And this is the moment where you always need to render viewport instead of render image. You do realize there's some problems with that because sometimes the modifier might have a difference between the render and the viewport subdivision. But I think this is a rather minor problem because personally speaking, I usually only change the render to 6, but I forgot to change this render to 6 as well, and so on and so forth. Basically, this is kind of idea. So whichever method you use, you just need to choose the one you prefer that solves the problem of this modifier issue. Again, this modifier issue is not a bug, it's expected, but it's unfortunately causing problem in this specific case. Finally, just kind of an interesting thing that the functional branch, I think is going to have a modifier option of functional deform. This is not a functional branch though, but it seems to achieve kind of effects that you can do with such kind of animation on the method. So maybe in the future you are going to have better method to do this kind of function. I don't know, but these are just whatever things. I think basically this is it. I'm going to stop here today. I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.